Welcome back, ladies and gentlemen. We are continuing at chapter 6.1 and our discussion on vectors. Specifically, the goal of this video is to define direction angles and be able to utilize that concept to find certain components of a vector. So let's talk first and foremost about a direction angle. Now, when we talk about direction angle, if you kind of think about it in a sense of when we were doing our discussions and our examples that were regarding things that said like due east or due west and something of the nature like that, or when they said so many degrees east of north, that kind of direction angle is what we are saying specifically. So now you don't have to write this down or anything, but just to kind of put it into perspective here. Like if, of course, this is the direction of north, and I said 30 degrees east of north, that is making a 30-degree angle, right, east of north. And now, of course, that could have been played around in a lot of different areas. And so that's what we are talking about in terms of a direction angle. And these direction angles actually have a lot to do with our vectors as well, too. And so let's talk here about how these are represented as vectors. Now, let's just kind of play around with the idea that let's say I have myself a vector, and let's say here, right here, is a vector. I'm going to call this guy just vector v, okay? So this guy is vector v. So what we can actually do is we can utilize the horizontal and vertical components of this vector and relate them using sine and cosine. Because remember back in our trig discussions, when we are talking about sine and cosine, remember cosine is kind of that horizontal component, and then sine is that vertical component. And so what I can actually do is I can represent the horizontal component of this vector v utilizing cosine. And so if I sit there and I say that this vector that I'm drawing here can represent the horizontal component of this vector v by taking that magnitude of the vector and multiplying it by the cosine of the angle theta. Well, where is theta going to be? Well, theta is going to be the angle that is created between the vector and the horizontal component. Similarly, excuse me, we can go ahead and talk about the vertical component in this retrospect, and that is going to be our sine. So if you kind of assume that this new red arrow that I just drew is our vertical component, we can say that that guy is the magnitude of v multiplied by the sine of theta. And this is what kind of represents that geometric look of the vector, right? The horizontal versus the vertical components of that. And that is where we end up with this concept that we can also rewrite a vector in terms of its cosine and sine of the direction angle. So let's take a look here first and foremost as to how we can utilize this in an example. It says find the components of the vector v with a direction angle of 115 degrees and a magnitude of 6. So the direction angle is 115 and it has a magnitude of 6. We want to do this without using a calculator or anything like that. So let's go ahead and I'm going to draw just a quick sketch as to what this might resemble here. And so if you kind of think for a sec, if I go ahead and have a direction angle at about 115 degrees, okay, that kind of represents where my vector is going to be. So I'm again just going to call this vector v because that's what it states. So vector v, it's got a component of a comma b. I don't know what that is yet, but I do know that it does in fact have a magnitude of 6, all right? So that means the magnitude of the vector does equal 6 at this point in time. And it says what it wants to do is using no technology, so not using any kind of graphing calculators, all right, except to maybe approximate the exact trig functions. So let's find these horizontal and vertical components. That's what it's asking. When it says find the components, it's saying find those horizontal and vertical components of our vector. So if the vector is equal to the components of a comma b, what we can say is that since we have a magnitude of 6, this vector can be rewritten as 6 times the cosine of 115 degrees, comma 6 times the sine of 115 degrees. And so then ultimately what we can do now is we can now use our graphing calculators, or just a calculator in general for this one, to identify that when you actually multiply 6 times the cosine of 115, you get roughly about negative 2.54. And then when you multiply 6 times the sine of 115, you get roughly about 5.44. And so that kind of helps us on out. So honestly, it depends on, but depending on where the situation is, you could technically leave it in our cosine and sine form, all right? Or you can go ahead and actually simplify it on out to find an approximation. It just depends on what they are asking and providing for.